Good morning students. Today we will be studying about the coordinate systems. In our previous lectures we had an introduction of classical mechanics. So our first topic is about coordinate system. So what is coordinate system basically? We have already studied about frames of reference. So frame with respect to which the position of a particle is located, or if its motion can be described, that frame is known as coordinate system. And there are three types of coordinate systems. First we have Cartesian coordinate system. Second, we have spherical polar coordinate system. Third is cylindrical coordinate system. So in our syllabus we will be dealing basically with these two systems, Cartesian coordinate system and spherical polar coordinate system. So where these three coordinate systems will be used. First we talk about Cartesian coordinate system. Cartesian coordinate system will be used for those problems which don't have any symmetry, which don't require any symmetry. In that type of problems we will be dealing with Cartesian coordinate system. And spherical polar coordinate system will be used where the problems will be having spherical symmetry. Though in those problems we will be using spherical polar coordinates. And then third is cylindrical coordinate system. Cylindrical coordinate system is when the problem it is having axis of symmetry. So here the problem will not involve any symmetry. In spherical polar coordinates, it is having spherical symmetry. And for the cylindrical, we will be having axis of symmetry. So now, we will be dealing each coordinate system one by one. So first of all, let us talk about Cartesian coordinate system. Cartesian coordinate system as we talked in the frame of reference, that if we are dealing with the particle in the space and we are having three coordinates like x, y and z, and all the three coordinates they are perpendicular to each other. For your demonstration, let us see this thing. Let us suppose this is x-axis, this is my y-axis and this is my z-axis. So all the three coordinates they are perpendicular to each other. No matter to whom will I say x, y or z. This can be x, this can be y, this can be z, or this can be x, this can be y, this can be z. But the thumb rule is all these three coordinates they should be perpendicular to each other and they should have a common origin. Like this. If I say this is my y, this is my x, this is z and this is my origin. Now all of you know about the unit vectors. If I say my unit vector along the x-axis is I cap, what does it mean? It means that the vector along x-axis it is having magnitude 1 because it is called unit vector and it is having direction towards the x-axis, and similarly towards y the unit vector is j cap and towards z the unit vector is k cap. And the beauty of these unit vectors is the magnitude is constant and direction is also constant. They are not moving, they are towards the x-axis. If I is to be towards the x-axis, then it is having a constant direction and a unit magnitude. And similar with the j cap and k cap. Now, if I place a particle over here, since we are initially dealing with the point objects, so we consider a point P. So it will be having coordinates x, y and z. And the distance between the origin and the point, that is r vector. So this is my distance from O to P. So such type of coordinate system is known as Cartesian coordinate system. Now there can be two types of Cartesian coordinate systems. One is a right-handed Cartesian coordinate system and second is left-handed Cartesian coordinate system. What does I mean by this? Right-handed and left-handed Cartesian coordinate system. So if I consider right-handed Cartesian coordinate first, let us say this is my x, this is my y. Now I have to see where my z will go. If I consider one screw, everyone is aware about the screws. I say if I move my coordinate x towards y in the anti-clockwise direction, listen carefully, if I move my x coordinate towards y in anti-clockwise direction, it means if I am considering a screw, I have to move it like this. This is anti-clockwise, like this. So if I move it like this, it will ultimately get towards upward direction. So direction of my screw will go towards upward. So it means the right hand screw rule says, right hand Cartesian coordinate or right hand screw rule says, if my x is moved towards the y or x replaces the y in the anti-clockwise direction, then the z direction will be defined by the direction where your screw will move. So if I am moving anti-clockwise like this, my screw is coming out in the upward direction, it means my z direction will be this. So here is my screw, it is going upward, z will be in the upward direction. This is right hand screw rule. And right hand thumb rule, if I say, if I take these three fingers, my central finger, if it represents y-axis, my thumb represents, central finger represents x-axis, my thumb will represent y-axis, then z-axis will be represented my forefinger. So this is right hand thumb rule. This will be applicable here also. If this finger goes towards the x, thumb goes towards y, then z will go towards the upward direction. So this is right hand thumb rule. Now if I talk about the unit vectors in right hand thumb rule, then I cross j will give me k, j cross k will give me I, and k cross I will give me j. This is my right hand rule, right-handed Cartesian coordinate system. Now let us talk about left-handed Cartesian coordinate system. In left-handed Cartesian coordinate system, let us say this is my x, this is my y. Now I have to say where my z will go. If I rotate it like this, that x will go to y in a clockwise manner. Then clockwise manner is like this. If x will go towards y, then what will happen? If I rotate it like a screw from x to y in a clockwise direction, it means it is going down. The screw will get closed. So it is going down. It means my z direction will be in the downward direction. This is my clockwise rotation. In the left handed we have to go with the clockwise rotation. So this is x, this is y. If I want to replace y with x such that it comes in a clockwise manner, then my z will go in the direction where my screw will go. Obviously it will be closed and screw will be going to downward direction. And similarly, if I take the left hand thumb rule, then the similar will be there. This finger, central finger, will represent my x-axis, thumb will represent my y-axis, and your C, like this. If something is coming out or going back, so z-axis will be going in the opposite direction. And about the unit vectors, we will be having I cross j is equal to minus k, because now rotation is being reversed. So this is about the left-handed Cartesian coordinate system. So these are two types of Cartesian coordinate systems. Now next is spherical polar coordinate system. So we will be discussing about spherical, polar and cylindrical, and then we will talk in detail about the Cartesian coordinate. Spherical polar coordinate system. As I told you that in spherical polar coordinate system we have to deal with all the coordinates on the surface of the sphere. So first of all, we will draw a sphere like this. We have three axes. We have three axes. Let us suppose this is my x, this is my y, this is my z, and here lies a point P having coordinates x, y, z such that the distance between the origin and a point is r, that is called a position vector. Now the angle which this position vector makes with the z-axis in the clockwise direction, that is theta. Okay. Now this point will have some projection over here. Now this projection, if I draw it with the vector, let us suppose this is O, origin, this is N. This is the projection, this ON is the projection of basically my position vector OP. So if I draw perpendiculars here, this is 90 degree, this is 90 degree. Suppose this is A, this is B. Now the angle which this projection makes with the x-axis is called phi. So now in this R, that is called position vector or a radial distance in this case. Theta is called zenith angle and phi is called azimuthal angle. Now this r, theta and phi gives me spherical polar coordinates. Like I was having x, y and z in case of Cartesian coordinates. Here I am having r, theta and phi as spherical polar coordinates. There are some properties related to this. Now first of all we will see the unit vectors. The unit vector along the x-axis is I cap, along the this y-axis is j cap, and along this z-axis, that is k cap, we can have any numbering, say d. Now the unit vectors along these spherical polar coordinates, that is r cap. Where the r cap is going? R cap will go in the increasing direction of the r. Theta cap will go in the increasing direction of theta, and phi cap will go in the increasing direction of phi. What does it mean? That the unit vectors of these spherical polar coordinates will go in the same direction in which their vector will go. So here we are having r is going like this, theta is coming like this, so theta is coming like this, theta cap, this is your r cap, and where is your phi going? Phi is basically like this. So phi is going like this in the anti-clockwise direction. So phi is like this. So these are the three unit vectors of the spherical polar coordinates, and they are changing. So this is the difference between the Cartesian coordinates and spherical polar coordinates, that in case of your Cartesian coordinates, we have observed that your I cap, your j cap and your k cap, they were having unit magnitude, means they were having constant magnitude and they were having constant direction. But in case of spherical polar coordinates, the magnitude is constant, like r cap, theta cap, phi cap. Magnitude may be constant, but direction is not constant. So this is the difference between the unit vectors of Cartesian and spherical polar coordinates. And another property of spherical polar coordinate is all the three unit vectors, they are perpendicular to each other, or they are orthogonal to each other, as we have observed in case of unit vectors of Cartesian coordinates, that I cap, j cap, k cap, they are perpendicular to each other. Similarly, this r, theta and phi unit vectors, they will be perpendicular to each other. So this is a bit introduction of the spherical polar coordinates. Now next is cylindrical coordinates. Your cylindrical coordinate is those coordinates which are having axis of symmetry. In cylindrical coordinates, let us suppose we have a cylinder of this type. This is my axis of symmetry. Now from here I am having a point P, that is a position vector from a origin to a point. Then its projection, same as the spherical polar coordinate, its projection will be somewhere over here. So this angle is phi, this is your z, and this is your rho, and the unit vector along the rho, that is rho cap, this is phi cap, and this is z cap. So this will give me the cylindrical polar coordinates. So here your projection is involved, and unit vector along that projection will be rho cap, and phi angle is your azimuthal angle again, and z is your z direction. So you can say z cap or you can say k cap. So rho, phi and z will basically be my cylindrical coordinates. So this is about the coordinate systems, three types: Cartesian, spherical and cylindrical, and we will be dealing with these in turn by turn in details. So our first topic is, we have to find the displacement, velocity and acceleration of a particle in Cartesian coordinates first. Displacement, velocity and acceleration in Cartesian coordinates. Now here also we have two types of problems. When your particle is moving in a plane, and second is when your particle is moving in a space. It means when a particle is moving in a plane means your particle is moving in a two-dimensional geometry, and particle in a space mean your particle is moving in a three-dimensional geometry. So if initially we talk about a plane, let us suppose we have a particle that is located in a plane having x and y coordinates. Here is a particle and its position having a distance r vector from the origin. Let us suppose after a time, this was for the time initially for time t, let us suppose after a time t plus dt, your particle moves to the another position. Now the unit vector along the x-axis is I cap, along y-axis is j cap. So the position, this is x and y coordinate, and what will be the position along this point P? The position will be r vector equal to x I cap plus y j cap. Since your particle is moving in a plane, so r vector will be a combination of your x coordinate and unit vector along it. Since this is a vector quantity and we have to make it a vector, so we will multiply the magnitude with the unit vector to make this quantity a vector quantity. Only then we can add the two quantities to get a vector. So x I cap plus y j cap. Now let us suppose after a time t plus dt, this position shifts to the another position, say, or I make this point as P, this is P, x, y, and this new position become P dash, and now since it has moved a distance of dx and dy, this distance is r plus dr, it will be a bit longer from this. So this is r plus dr and this is your dr vector. Suppose the vector from O to P is in this direction, this is in this direction, OP dash will be like this. So here the coordinates will be x plus dx and y plus dy. So what will be the coordinate or what will be the position of vector at this point P dash? The position vector in this point will be at P dash, that is x plus dx. This was my OP. This is my OP dash plus y plus dy. Now you know the triangle law of vector. According to the triangle law of vector, OP plus PP dash, all the two vectors, they are in the same direction, so they will get added, and the third will give me the resultant OP dash. So what will be my PP dash? PP dash will be OP dash minus OP. I can fill the values. This is x plus dx I cap, y plus dy j cap minus x I cap minus y j cap. So this gets cancelled with x and y. So you are left with dr equal to dx I cap plus dy j cap. So basically this is my position vector. So I just wanted to find the displacement. So this is my displacement. how much my point gets displaced from the point in a time will be given by dr, and dr is a combination of dx and dy, that the moment of a particle along the x-axis plus the moment of a particle along the y-axis in a vector form, when gets added, it will give me a displacement. So now if this is the vector form, if I want to get the magnitude, how can I get the magnitude? I can get the magnitude simply by saying this. If I put a mod, this quantity becomes my magnitude. This will give me dx square dy square. So this is my displacement in magnitude. Now I want to find the velocity from here. Everybody knows what is velocity. Velocity is a rate of change of displacement with respect to time. So rate of change of displacement with respect to time. If I see this, I have this equation dr dx plus dy j cap. If I divide both sides by dt, then it will give me dr by dt equal to dx by dt plus dy by dt j cap. Now this is my velocity. This is v. Dx by dt. This gives me the velocity along the x component. So I can write it as vx I cap. This gives me the velocity along the y component, vy j cap. Or I can have one notation that we will be using in the whole unit, that I can write v is equal to x dot, where I can write dx by dt is equal to x dot. I can just donate it, and dy by dt equal to y dot. So v is x dot I cap plus y dot j cap. This gives me velocity. Similarly, I can get the magnitude of the velocity. Under root of x dot square plus y dot square. Now third comes the acceleration. You know what is acceleration? Like velocity. Velocity was rate of change of displacement, and acceleration is rate of change of velocity. So acceleration is a rate of change of velocity. So if I put the equation, A will be dv by dt. So my v is this. V is x dot I cap y dot j cap. If I differentiate both sides, I will get dv by dt is equal to dx dot by dt I cap dy dot by dt j cap. So I can write acceleration because this gives me acceleration. So this is your component of acceleration along the x-axis, and this is the component along the y-axis. So I can write ax I cap plus ay j cap, or I can also write a is equal to x double dot I cap plus y double dot j cap. So this gives me acceleration. I can also take the magnitude by a equal to x double dot whole square y double dot whole square. So that will give me acceleration. So this is about the displacement, velocity and acceleration in the Cartesian coordinates in the plane, if your particle is moving in a plane. So we will be solving a problem for a particle that is having Cartesian coordinates and moving in a plane. Let us suppose a particle that is moving having its position at x equal to 4 by 3 t cube minus 2t I cap, and its position along the y is t square. Let us say this is t square. Then we want to find the displacement, velocity and acceleration. How will you find the displacement? R is xi cap, yj cap when it is given that your time is 2 seconds. So you will simply put the values 2 minus 2t, that is t is again 2, I cap plus y, t square, that is 2 square, j cap. So 4 by 3 into 8 minus 4 I cap plus 4 j cap. So if I take the magnitude over here, so I can get this square plus this square under the root. This will give me the position. Now if I want to find the velocity, how will I find? Velocity will be, I just differentiate this with respect to time. So Vx is 4 by 3, that is dx by dt. So you differentiate this. It will be 4 by 3, 3t square minus 2. Vy will be 2t. So if I combine these two and put the value, t is equal to 2 seconds. So your v is vxi cap, vy j cap. You can put these two values here. So it will be 4 into 4 minus 8 I cap plus 2t, that is 2 into 2, 4. So this is how you can get the velocities. Similarly, acceleration. For the acceleration, you will just differentiate these. So acceleration will be ax I cap plus ay j cap. So your ax will become dvx by dt. You will just differentiate this and put here, then put the value of t. I am giving you just hints and you can solve it by yourself. Then ay is dvy by dt. So this is the position, velocity and acceleration in a plane. Now one assignment for you that you will be doing, we have discussed the motion of a particle like displacement, acceleration and velocity in a plane. Now your assignment is, you have to do displacement, velocity, acceleration of a particle in space. So for your hint, if a particle is in a space, it will be having 3 coordinates, that is x, y and z. So if particle is here, then it will be having coordinate x, y and z, and this is r. And suppose after a time t plus dt, this goes to the another location p dash. This is your dr, this is your r plus dr. So here the coordinates will be x plus dx, y plus dy and z plus dz. So you will find the location, displacement. Displacement will come out to be like this: dx I cap, dy j cap and dz k cap. In case of your Cartesian coordinate in a space, then your velocity will come out to be vx I cap, vy j cap and vz k cap, where your vx will be x double dot, y double dot and z double dot, and your acceleration will be ax I cap, ay j cap, az k cap. So ax will be x double dot, y double dot, z double dot. Here it will be a single dot and here it will be a double dot. So this will give you displacement, velocity and acceleration in the three-dimensional geometry. Now we can have one problem for the three-dimensional geometry. Let us suppose the position of a particle is described by x is equal to 4 sine 2t, y is equal to 4 cos 2t and z is equal to 60. Then you have to find the velocity and acceleration. So first of all, what will be r? Position. It will be xi cap, yj cap, zk cap. So it will be 4 sine 2t I cap, 4 cos 2t j cap and third one is 60. Now if I want to find the velocity, what will I do? I will just differentiate it. If I differentiate this, it will give me 4 sine. What is the differentiation of sine theta? Sine theta differentiation is cos theta. So 2 will come out. It will give me cos 2t I cap plus 4 cos theta's differentiation is minus sine theta. It will give me minus 2t plus 6. So let us suppose if a value of t is 1, or we need not to have a value, we can just have a answer in terms of t. Now this will give me velocity if I solve it. Acceleration will be given by differentiating this equation. So when I differentiate this equation, I will get the acceleration. So this is how we deal with the Cartesian coordinates. We find the position, displacement and acceleration. So this is all about the Cartesian coordinate system. So in our upcoming lectures, we will be discussing about the spherical polar coordinates, and in the initially we will be doing the relation between the Cartesian and the spherical polar coordinates, and then we will discuss about the displacement, velocity, acceleration in spherical polar coordinates. Thank you so much.